Nintendo Switch. Let's see what's going on real quick. This is reportedly a port issue. And you can see it's had some torque going on. So yes, it probably does need to be replaced. And that center area is very bouncy and it should not move at all. So yep, we definitely have a port problem. So we'll have to disassemble, remove the port, remove the board, remove the port, and then we'll do some testing. I don't think there's any pins touching, but with that center plastic area being so wiggly, there could be some breakage in between, and the pins on the tops and the bottom could be making contact. So I don't want to do a power test right now, and I don't want to do any measuring with the multimeter until the port is off, because I think it will interfere with our readings, or potentially could do so. So we'll just remove the port, then we'll do our testing, and then we'll go from there. And we're back, and we're getting set up to do the port. While I am setting up my equipment, throw my expected temperatures up for this job. Switch you back to microscope. As always, those temperatures are subject to change if the job changes, but probably won't. That's generally what I use on Nintendo Switches. Alright, so we're going to do what we always do. I'm going to flood these anchors with low melts, and we'll flood the pins we can see with low melts. And that's just eliminating those things as variables. Once the center pins are ready to go, wetted and ready to go, everything will be wetted and ready to go. There will be no doubt about it. I'm now positioning my tweezers to catch the port. I don't want it to fly off with too much momentum. I don't think this will be a case of pull pad. It is a case of pull pads, but it won't be, it could be worse if it just flew off. So it looks like we got 1, 2, 3, 4, 5, 6, 7 pull pads on this one. And this job just got more interesting. Let's take a look and make sure we have no bridge connections, because we don't want any bridge pins when we're doing our testing, because that will interfere with our results. So that looks good. Alright, let's start our testing where we always start, and that is right here on this capacitor. This capacitor has a line that goes to the M92T36 and ends up where the Pi 3 USB is on the other side of the board. If this capacitor and on that line tests bad, it's usually because you have a bad Pi 3 USB. Okay, and you have good connection, and it looks like it's testing all right. Now we're going to test the lines going to the chip from every capacitor. There is one capacitor that has 2 lines going to the chip, and there will always be one side that's ground in that case. But otherwise, we generally do not want those lines to be shorted. Okay, we do have a short there, we have a short there. We have 2 capacitors that are short on the M92. Check our MOSFET area. Check our little filter. Okay. Check our invincible fuse that never protects anything. Well, I don't say never, but almost never. About the same percentage of a MacBook backlight fuse. Almost never. Let's check our test pads. We do not want any of these reading short. And this one's reading short. And we already know we have a bad M92T36. But these test pads can oftentimes reveal that you have a bad M92T36 that is not presenting around the chip. But in this case, it is presenting around the chip. So this is a bad shorted test pad. All right. Let's check around our BQ24193. Same situation on the BQ. Some of these, it actually has two capacitors with two lines going to the chip. I just happen to know which size to test. Alright, let's make sure our coil is not short to ground, and then we're getting continuity through it, and everything seems okay over here. I'm going to flip it over. Alright, let's check all of our little filters first. You may have to work your way through some gunk sometimes, so don't get trolled. A lot of times there's some manufacturer residue on here as well that you have to get through. Okay, I'll make sure these are not shorted to ground. Okay, and let's make sure they're not getting continuity side to side. Alright, and we'll check our big capacitor on the Pi 3 USB, and it seems fine. So everything in that area looks okay. Alright, let's remove the chip. So it's good to make sure that your shorts have disappeared. And they appear to have disappeared. Wet the solder again. Should still be relatively warm. We want the center pad to wet, and we want to make sure the chip has been grabbed by the solder before you let it go, otherwise it'll go flying off. Let's center it. That's not well centered. There we go. Yeah. I jumped the gun. Okay, take the heat off. Then press. I'm just mainly looking for any micro bridging. Between pins. And I don't see any. Alright, everything looks good. Let's test those capacitors again. Make sure our shorts did not reappear. Alright, everything looks good. We'll also check our test pads because one of those was short. And that short is left as well. Very good. We need to clean this up and get a better look at what we're dealing with. Okay, as always with wicking, if you just kind of want to glide, you do, like you're skating over ice, you don't want to be pressing down. This is not a scrubber. Just glide right over. In the case of these pads, you generally want to go with the pads. You don't want to be scrubbing across them. You can get away with that on some devices, but not the Switch. I don't recommend doing it on the Switch port. Okay, we're going to some indirect lighting so I can see the traces a little better. And we're going to grab our new favorite tool, the pin grinder. If you take a look up in the top left. This thing has been awesome. Been very happy with it. Every once in a while you get those tool purchases, you're like, oh, this is just great. I'm going to start grinding on a trace that we don't need to grind on though. That one's a bit weak. Okay, I think those are the only important ones. I believe this one is ground and this one is ground, but we will meter those out just to be sure. Ground and ground. So we are not concerned with those guys. This one doesn't give us a lot to work with, so I want to make sure it's well clear. Alright, I want to tin everything up here. Get some solder on the tippy tip. So we're not hitting things we don't want to hit. What you're seeing here is just a little bit of a green board that I keep around just for doing jumper wires. This is what underneath the wire here. It's the best thing to be tinning them on, at least I've found. For running the jumpers, I am using my Pico pencil with the micro bezel tip. It's hard to tell it's a bezel, but it is. Don't like how close that is to the other pad, so let's see if we can scoot over. Don't want to have to rerun these after cleaning. There we go. That's a much better joint. I'm angling the wire down in the tweezers because I kind of wanted to have leverage onto the board while we're tacking it down. Yep, did not have a good joint on that one. That was too easy to pull away. See if I can get that centered. Still not liking that joint too much. Having some issue getting solder on that joint. Well, that wire doesn't want to move now, though. Alright, I like that joint a little better. This is all in an effort to not have to keep redoing these. See if they survive cleaning. You want to be gentle with the cleaning, but you don't want to be overly gentle because you need to know if your joints are going to hold up. So I just kind of lightly glide, but I don't, I'm not being overly delicate. I am trying to only hit it going one way because you don't really want to hit it going back that way. That would be a little too rough. Looks like everybody survived. Straighten them out. Just want to get them center pad as much as possible. And now we'll set up and do the solder mask. We just want a little bit on each side, nothing too crazy. But we do want it well secured down. When we go to put on that port. You want to cover the solder joints that they're connected with, because that solder joint will wet when you go to put the port on, but you don't want that jumper to move. There's a fine line with this though. You do not want the solder mass to be sitting up high. You want to spread it out thin, like this big glob, well, big microscopic glob I've got here. You want to thin that out real good. Because you do not want any humps, especially you don't want them to be higher than the jumper wire. We'll have problem with connections. Ask me how I know. Alright, should be adequate. Alright, next part of the task is to grab my UV lamp. I'm just going to set it on there and walk away for about 10 or 15 minutes and let it cure really good. You want a really good cure. I have a laser, but I get way too impatient with the laser, and I've had issues with the jumpers getting sucked into the port when I use the laser, so this is the best method for me. I put my UV lamp on there, I walk away for about 10-15 minutes, have a break, you know, have a snack or something, and then come back, and then we should be ready to put on the port. That's my big UV lamp. It's just going to sit there on the board for 10 or 15 minutes. Okay, that looks pretty solid. But the true test is when we tin them. What we don't want to happen here is for the wire to get sucked up into the iron. Again, we need to know if we're going to have a problem now. All right. Look and make sure nothing's loose. And still solid. Excellent. So that is good. We'll just add to that flux. We didn't really use much of it, so that should be adequate for the port. Let's tin up the port. That's a healthy amount of flux on there to prevent bridging. Looks good. Okay, and we'll use our, typical normal placement method of warming up the board enough to wet the solder, and we'll move the nozzle rapidly as to keep from melting any plastic or anything. Solder's wetting. We'll go a little bit longer, make sure we get those center ones, the hidden ones. Press down, concentrating on the hidden ones a little bit as well. Move the heat, but we'll keep holding it down until we see the visible pins dry. I'm going to do my slight nudge test here. And it feels pretty solid. You don't want to put a whole lot of pressure on it, but it shouldn't get any movement really if both rows are soldered down. Just want to rub it into the joint a little bit so it'll climb up the leg. You want the heat to climb, it'll follow the heat. So. When you're rubbing it like that, don't put any pressure on the leg though. You could end up loosening things up. Sure, we got good feed through, and we got excellent feed through. Very good. I don't think that one was solid. Okay. We're going to go over these. Check them again. All right. Very good. Okay, all cleaned out and blown out. I want to do some testing real quick just to make sure we have nothing to short at the ground that shouldn't be. With jumpers, it's probably a good idea to always test before you proceed to plug in power. Okay, none of the test pads are shorted. I'm also going to check the filters. All right, now we're ready to perform a test with our PSU. Be watching the amp meter on the far left, channel 1. Okay, being a little bit odd with the PSU. It does happen. All right. That looked relatively normal. Try the other side again. That looked relatively normal. For this, you'll be watching the meter on the far right, on your far right, and the amp meter, channel 2, and we'll be activating with the OEM. And what we would just want to see here is a steady climb in amperage. All right, that looks pretty good. This is not the end-all be-all. We have to put it in the housing and perform tests. We'll test with the charged battery, and of course the ultimate test is testing the dock. So, especially when you're running jumpers. So, hopefully all those tests go well. Otherwise, we'll have to pull out the breakout board and see what we're missing. Okay, we're together enough to test, and I have my charged battery in it, so let's plug some power. Full battery symbol, that's a good sign. It's in the switch logo. And powered up. Let's check the other side, we are fast charging. Okay, stop being... It's recognizing it, but it's being a bit of a pain. I think it's a PSU issue. I hope. Come on. Okay. I'm going to have to grab my inline meter and check with the OEM because I'm not sure it's charging on both sides, even though it's showing that it's charging on both sides. We're not pulling the current I'd be expecting. Okay. Flip around. Okay. We are charging on both sides. It would appear normally. I think it's just playing up with the PSU again. So we'll power down, let it charge on its own battery for a while, reassemble enough to do a dock test, and go from there. Okay, and as you can see, it is docking, so that is excellent. First try. I love it when we get it on the first try. I don't like having to go back and try to figure out what signals we're missing and all that stuff. So we'll come back and do the rest of the testing. But I wanted to check the dock first thing, because if the dock isn't working, we're just going to have to go back and deal with it. Okay, it's docking. We saw that. Now we're going to make sure everything is charging normally. If you see on the USB meter section, it is fast charging at 15 volts, which we expect. It is charging both of my Joy-Cons, which is good. And check our internet. Make sure we're picking up all our networks. We don't have any additional Wi-Fi issues. Picking up our networks, good. Okay, well that's really going to be it for this repair. I just got to reassemble it and get it back to the customers. In summary, we had a looked like a slightly torqued up or dorked up port. It was didn't look like the damage was going to be that bad, but when we removed the port, we found several, I think 5 needed torn pads. There were 2 additional ones that were just ground, that weren't a concern. We pulled the port and found those torn pads, and then when we did our normal testing, our power circuitry testing, we found found quite a few shorted things on M92 T36, and a test pad that was shorted that was also linked to M92 T36. So we replaced the chip, we ran our jumpers, replaced the port, and everything is good to go. It's docking and charging and everything normally. That's excellent. Anyway, that's all I have for you. If you have any questions about the equipment I used in this video, take a look in the description below. They're all Amazon linked down there, so if you click on any of those links and buy anything during that session, it doesn't have to be one of the tools. A small portion of that will go to supporting the channel, and we greatly appreciate it. I keep investing in equipment on the channel, and the channel is definitely not making money at this point. So there are also other support links in the description if you want to use those instead. And again, much appreciated if you choose to. And that's really all I had to ask of you. If you like the video, do me a favor, hit the like button. And if you want to see more videos, hit the subscribe button and notification bell, and you'll know when I post videos. Appreciate you watching. We'll see you next time.